Hi, myself Dr. G. Naresh Reddy, an Institute Postdoctoral Fellow in Department of Chemistry, IIT Bombay. Today I am going to demonstrate an experiment 1. The title of the experiment is Acidimetry Alkalimetry titration. So the main aim of the experiment, it is under the course of preparatory chemistry course. The main aim of the experiment is to estimate the amount of sodium hydroxide present in the solution. So we have also provided here the 0.1 normal sodium carbonate and approximately 0.1 normal H2SO4 solution. I am going to demonstrate experiment 1, acidimetry alkalimetry titration under the course code of CH011L111L. So it is a preparation course in chemistry department. So here the main aim of the experiment is to estimate the amount of sodium hydroxide in the given solution. Here we can supply with 0.1 normal sodium carbonate and approximately 0.1 normal H2SO4. So before going to start the experiment, I want to explain about some terms. That is, first one is titration. It is a laboratory technique that measures the concentration of an analyte using reaction between analyte and standard solution, that is a solution of known concentration. And what is acidometry? Acidometry is the determination of acidic substances by titrating with a standard base solution. And the alkalimetry is the measurement of concentration of basic substances by titrating with a standard acidic solution. And as we all know that the combination of hydride ion plus and hydroxide ion will give salt plus water. And also the object of titrating, say, an alkaline solution with a standard solution of an acid is the determination of amount of acid which is exactly equivalent to the chemical to the amount of base present. That amount we are measuring in this experiment. Coming to the next slide. Actually, coming to the procedure, here actually we are initially doing the standardization of H2SO4. For that, we need to pipette out 10 ml of given 0.1 normal sodium carbonate solution into a 100 ml conical flask and titrate with H2SO4 taken in the burette using methyl orange as a indicator. And the methyl orange pH value is in acidic media, so that is lower than 7. So for neutral molecules, the pH is 7. The methyl orange pH is lower than 7, that is acidic. So the end point is from yellow to orange, we can observe in the titration, and we need to repeat the titration until 2 consecutive titer values, and it should not differ by more than 0.1 ml. And after from this we can calculate the normality of sulfuric acid. So after getting the normality of sulfuric acid, we can estimate the amount of sodium hydroxide. So to estimate the amount of sodium hydroxide, we can make up the given sodium hydroxide solution in the volumetric flask up to the mark of 100 ml using distilled water, and we need to shake well to make the solution homogeneous. And after that we need to pipette out 10 ml of this diluted solution into a 100 ml conical flask and titrate with H2SO4 taken in the burette using phenolphthalein as an indicator. The end point is from pink to colorless will come. So then the end point we can see the color change, and repeat the titration until 2 consecutive titrate values will appear. So from this we can estimate the amount of sodium hydroxide present in the solution. So coming to the next slide, here I have given some tips for titration. So the first tip is the solutions must be shaken well before starting the experiment, and also first a known volume of the analyte is placed in a flask and a few drops of an acid base indicator or any indicator like such as phenolphthalein or methyl orange are added for that. Then next the standard solution is placed into a burette. This solution is also called as titrant. Then the titrant is added drop by drop to the analyte while swirling the flask. Titration must be performed slowly and always hold stopcock one hand while swirling the flask with other hand. Why? Because when the color will change, we need to stop the stopcock. Here I have shown some pictures. So we need to transfer the solution into the burette by using funnel only. Without using funnel, if you will transfer the solution into the burette, so some solution may go out. So that's why we need to use funnel to transfer the solution into the burette. And these are the this indicates that the knob is closed, and this indicates that the knob is open. So we should take care of that. Here one more thing is that the air bubble is present during the titration. That should not be a air bubble. If air bubble is there, then the volume readings may be have some errors. So that's why we should take care of that. And one more important thing is that we need to keep a white paper below the conical flask. Why? Because from this this one may help you to determine the endpoint and color change also clearly. So here we can add drop wise the indicator, and we need to do the titration in this way by handling with knob with one hand, and with one hand we need to hold a conical flask. So we need to see the color change below, and here you can see if you will keep the paper under the conical flask, you can able to see clearly the color change of the solution, and we can see here the readings by keeping any mark. To start the titration, we need to have some chemicals, that is H2SO4 and sodium carbonate for standardization, and we need to use in this experiment two indicators, that is one is methyl orange and other is phenolphthalein indicator, and we need to calculate the amount of sodium hydroxide unknown. This is the unknown solution sodium hydroxide given. So here we need to use some operators, that is this is the pipette pump. So here which helps to measure the 10 ml of solution accurately. So in this pandemic it is very useful. Instead of mouth, if you will use this one, it is good. So here we are using the 10 ml pipettes, we require. So and also we need two beakers to transfer the H2SO4 solution into the burette. One is required, and to transfer the waste solution into the beaker. So and we need to have the conical flask. This is also called as titration flask, we can say. So we will perform the titration with this one. So and also we need a water to wash, and also we need to have funnel to transfer the H2SO4 solution into the burette. At first I want to do the standardization of H2SO4. For that I am taking in burette the H2SO4 solution by using this small funnel. So make sure that we need to close this knob while transferring the H2SO4 solution into the burette. We need to take H2SO4 solution into the burette up to 50 ml. Now it's more, so I am removing the H2SO4 remaining extra H2SO4 solution into the beaker, waste beaker. Now the H2SO4 solution in burette up to 50 ml. Now I am taking 10 ml of 0.1 normal sodium carbonate solution into the conical flask with the help of pipette. This above one is called as roller, so it will suck the solution into the pipette. So here we have used 10 ml pipette. So there is a cut mark. Up to that cut mark we need to take. So now the solution is up to cut mark. So now this one I am transferring into the conical flask with the help of this bar. If you will press this bar, then total solution will transfer into the conical flask. So after adding 10 ml of 0.1 normal sodium carbonate into the conical flask. We need to add methyl orange indicator. Just 2 or 3 drops we need to add. After adding 10 ml of 0.1 normal sodium carbonate solution into the conical flask, we need to add 2 drops of methyl orange indicator. So after adding methyl orange indicator, the color becomes yellow. You can see in conical flask. After adding methyl orange indicator, the color becomes yellow. So now we need to start the titration with H2SO4 solution. So when the independent will come, so that time the color will changes from yellow to orange. Now we need to start the titration by adding drop by drop H2SO4 solution into the conical flask. Here what happens is that, so the sodium carbonate is a base and H2SO4 is an acid. So at particular point, so the total H2SO4 and sodium carbonate will neutralize. That means the pH will become 7 at particular point. After that, the indicator color will changes from yellow to orange. See, now the color is changed from yellow to orange. Now look at the burette. So we need to note down the burette reading. So after that we need to continue the titration to get 2 consecutive titrate values. So now again I want to take the 10 ml of 0.1 normal sodium carbonate solution. Then I want to add the methyl orange and I want to continue for remaining 2 consecutive values the titration. Now we need to estimate the amount of sodium hydroxide solution. For that we have taken unknown sodium hydroxide solution and we need to make up this one in volumetric flask up to 100 ml with water. This up to the cut mark we need to fill with water. Okay. Now we make up the solution up to 100 ml in volumetric flask. After that we need to shake it to mix the both water and unknown solution. So after that we need to take 10 ml of this solution into the conical flask to start the titration. So here also, in this case also, in burette we are using H2SO4 solution. Now we need to take 10 ml of sodium hydroxide unknown solution into the conical flask by using different pipette. So here initially we have used for standardization of H2SO4 the other pipette. This is a new pipette we are using. So by using this pipette, we need to pull out 10 ml liquid into the pipette. Now this 10 ml liquid is transferred into the conical flask by pressing this bar. After transferring 10 ml of sodium hydroxide solution, we need to add the indicator. In this case, we are using phenolphthalein indicator. So this indicator also we need to add 2 or 3 drops. See, now the color changes to pink after adding phenolphthalein indicator. Now to start the titration, so we need to add drop by drop H2SO4 solution into the conical flask. It is like acid base titration. Here actually sodium hydroxide is the base and HCl is acid we are taking. So here after adding H2SO4 solution, so at particular point it will neutralize, then the indicator color will change. See, now the color changes from pink to colorless at the end point. When the color changes, I stop the knob. You can see that the pink to colorless change. Then you can see in burette we need to note down the reading and we need to continue this titration to get 2 consecutive titrate values. So coming to the calculations, so first of all we have done a standardization of H2SO4. So we have actually known value that is 10 ml of sodium carbonate we have taken. So that is 3 consecutive values we have done. So 10 ml, 10 ml, 10 ml we have taken. So from the burette we will get the volume of H2SO4 solution V2 we will get. So that 10 ml of 0.1 normal sodium carbonate titrated against. So this burette reading ml of H2SO4 we will get. So that by using this formula we can calculate the normality of the H2SO4 by using the formula of N1V1 equals to N2V2. So here N1 already we know, so that N1 is 0.1 normal and V1 we know that the 10 ml of sodium carbonate, so that means V1 is 10 ml. So we need to find out N2, that is the normality of H2SO4 we need to find. So V2 we will get from the burette readings. So from this we can get N2 value of, that means normality of H2SO4 we will get. After getting this, so we need to estimate the amount of sodium hydroxide in the given solution. So for that we again need to do titration for this. Here also we know the volume of sodium hydroxide, that is 10 ml, and from the burette readings we will get the volume of H2SO4 solution. So from this we can calculate the normality of NaOH solution, that is 10 ml of given NaOH solution titrated against this burette reading ml of this H2SO4. That already we know that normality of H2SO4 we can get it normality of H2SO4 solution from the standardization of H2SO4. So by using the N2V2 equals to N2V3, that is same formula, by using the same formula we can get the normality of sodium hydroxide. After getting the normality of sodium hydroxide, we need to calculate the amount of sodium hydroxide in the given solution, that by using the normality formula, that is N3 equals to weight by molecular weight into gram equivalent weight into 1000 by V. That is 1000 by V is here 10 ml we have taken. So the gram equivalent weight of sodium hydroxide is 40, and the normality of sodium hydroxide we can get it from the titration. So from this we can get the amount of sodium hydroxide given in the solution. In grams we can get it. Thank you. So finally we have done the standardization of H2SO4 solution and also estimation of amount of sodium hydroxide present in the given solution. So thank you.